Hello everyone and welcome to my channel Kanchan's Gate Mechanical Lectures. In today's video, we will discuss about the different types of stresses. So, the types of stresses can be distinguished mainly in two categories. One is in terms of nature of stress and the other is in terms of dimension of stress. So when we talk about the nature of stress, we mainly uh, deal with the way the external force is acting on the body or the impacts that are created by the external force. And these are mainly shear, normal, which we will discuss in detail in our next part. And in terms of dimension of stress, uh, this is mainly based on the dimension in which the stress is acting. For example, uniaxial, biaxial, triaxial. Now this is the broad classification of stress. So stresses are broadly classified into three categories. One is direct or simple stress, indirect stress, and the other is combined stress. Now direct or simple stress is the simplest form of stress. It is divided into two categories again, normal stress and shear stress. Normal stress can again be categorized into two parts. One is tensile stress and the other is compressive stress. Now indirect stress are mainly of two types. One is torsional shear stress and the other is bending stress. Combined stress is actually a combination of direct stress and an indirect stress. Now here in today's video we will only focus on direct or simple stress. In our future videos we will deal with indirect stress and combined stress. In terms of dimension of stresses, okay, dimension of stresses can be classified into three categories: uniaxial, biaxial, and triaxial. So in order to put it in simple terms, uniaxial stress is the stress which acts only along one axis, x, y, or z. Biaxial stress means the stress which acts in two dimensions, x or y or z, z or x. And triaxial stress means the stresses are acting in all the three dimensions. Now I will discuss about direct or simple stress and its different types. Now we will discuss about direct stress, or also known as simple stress. Now as the name suggests, direct or simple stress is the direct implication of the external force that is acting on the body. In order to distinguish, we can understand in this way that an external force can create bending moment as well as it can create torsional effect on the body. Now bending moment itself creates a different type of stress called as bending stress, and torsion creates a different type of stress called a torsional shear stress. Now bending stress and torsional shear stress are not the direct implication of the external force. It is the indirect implication of the external force, also known as indirect stress. When we talk about direct stress, it is the simplest impact of the external force and it is the direct impact. So forces, all direct or simple forces are just nothing but the resultant internal restoration force created, P, divided by area, and the SI unit is Newton per meter square. So this is the simple formula of direct stress. As you can understand, P was the resultant of the internal restoration force that is generated in the body in order to prevent its deformation caused by the external force, and A was the area on which the force was acting. I have discussed about this derivation in my previous video. So this is the formula for direct stress. Now direct stress can be of two types. One is normal stress and the other is shear stress. So let's see what is normal stress. Say for example we have a cylindrical bar which is hung from a rigid support. Now here an external tensile force is acting on this cylinder. The area of cross section of this cylinder is A. So this P is acting normally on this cross section. So if I see the front view of it, my cross section will appear something like this, and the area of which is A. So my P force is acting normal to this cross section. This is an example of normal stress. Now this external force which is acting normal to this cross section will create a direct stress which will be known as the normal stress. So normal stress we normally symbolize it as sigma, and that is equals to P divided by A. Now please note A is always the area on which the force is acting. So here in case of normal stress, this P is acting actually normally on this surface A, on this cross-sectional surface area A. So the normal stress sigma is P divided by the area on which it is acting normally, and that is A. Now there can be other examples of normal stress as well. This is an example where the force P is acting normally on the cross section. But there can be other example where there are multiple force acting from all the three dimensions, all equal in magnitude, but it is acting on the external surface of the body. Say for example, we take a body like this, and it is immersed in a liquid. So in that case, this body is acted upon by a constant hydrostatic force P from all the directions. And the surface area of this body is A. So in this case, this external forces P are acting from all the directions on the surface area A. So in this case, the normal stress will be given as this external force that is acting P divided by the surface area of the body. This is also a normal stress since all these equal magnitude forces are acting normal to the surface of the body. Now normal stress can again be classified into two types. One is tensile and the other is compressive. So tensile normal stress is that stress which causes elongation in the body. For example, this is a case of tensile normal stress, because here we can see that this force P is trying to elongate the body. So this is a tensile normal stress. Similarly, another type of normal stress can be compressive normal stress. So compressive normal stress is just the opposite of tensile stress. I mean, the direction of the force will be just the opposite. So here the P is acting downward to elongate it. In case of compressive force, the external force will act somewhat like this. It will act in the upward direction so as to compress it. Now compressive force, the magnitude of the force will again be the same. It is P by E. Okay. Now in case of this type of stress, this is already an example of compressive stress, because you see the forces are acting from all the three directions and they are trying to compress this body, reduce the volume of this body. So it is already a compressive stress. A tensile counterpart of it will be when there are multiple forces acting from inwards to outward. Magnitude of the forces are same in all the three dimensions, all the three directions, but they are acting from inside to outward, trying to increase the volume of the body. In that case, the formula will be that same, P by area. Now in strength of material, uh, a convention is used, that is tensile stresses. This is same for all types of stresses, whether it's direct stress, indirect stress, or combined stress. Tensile stresses are always taken as positive and compressive stresses are taken as negative. Now please note, this is not only for direct or simple stress, it is for indirect stress also. It can be for combined stress also. Tensile is taken as positive, compressive is negative. This is just a sign convention. Now let's discuss about another type of direct stress, which is shear stress. Shear stress. Now shear stress is caused in a body when a shearing force acts on a body and tries to shear the body. Now let's see what is a shearing force. A shearing force is actually a force which acts tangentially on the surface of the body. So say for example, we have a body like this and it is somewhat fixed at the bottom. Now a tangential force F acts tangentially to the upper surface of the body, in this surface, upper surface of the body. Now when this force acts on the upper surface of the body, this body undergoes an angular deformation, which is phi. This is called the shearing of the body. This tangential force F caused an angular deformation in the body in this way. The body slightly tilts and it gets sheared. In this case, this force F is acting on the area A. Now this A is not necessarily the area of cross section. This A is the area on which the shear force F is acting tangentially. In this case, the shear stress that will be developed in the body, and it is denoted by tau, is equals to F divided by area. Please note, this is an example of direct shear stress. So here a direct force is acting on the body and causing shear on the body. So we are taking the force directly divided by the surface area on which the force is acting tangentially and causing the shear on the body. It's called the shear stress. The SI unit of it will be again Newton per meter square. So we have discussed about what is direct or simple stress. The two types of direct stress, one is normal stress and the other is shear stress. And normal stress can be again two types, one is tensile and the other is compressive. Next we will discuss about types of stress based on the dimension. Now based on the dimension of stress, stresses are mainly of three types: uniaxial, biaxial and triaxial. Now uniaxial stress, as the name suggests, is the stress which acts on a body along one single axis. So say for example, here we take a cylindrical body whose axis is directed along the x-axis. Now if it is subjected to only one force P only along the x-axis, then the stress that is caused, the normal stress that is caused along the x-axis, is sigma x. There are no stresses created along the y-axis or z-axis, just one stress sigma x produced along the x-axis. So this is called uniaxial stress. In case of uniaxial stress, the stresses along all other dimensions y, z are 0, or it can be x, y and 0, or it can be z, x and 0. There is only one dimension of force, one dimension of stress, that's either along x or y or z. Now here I have shown an example of tensile stress. It could be compressive as well. If it becomes compressive, then the direction of P reverses. Now when we talk about biaxial stress, if we put it simply, so this is uniaxial. Now we're talking about biaxial. Now when we talk about biaxial, to put it simply, we can say that there are two direct stresses, sigma x and sigma y, acting along two dimensions. One is x and the other is y. This is called biaxial stress. Now here I am showing only x and y. It can be along y and z, or it can be along z and x. Now the last one, that is a triaxial stress, which by now you might have understood. If I consider a three-dimensional body, if this is subjected to stresses in all the three directions, then this is called triaxial stress. So here you can see that there are sigma x, sigma y and sigma z along all the three dimensions. Now this can again, now here I have used only tensile stresses. This could have been all compressive stresses, or it could have been a combination of tensile or compressive stress. Same thing goes for biaxial as well. So we have discussed about the nature of stress based on dimensions. In my next video, we will discuss about the different type of strengths. So meet you again in my next video. Thank you.